We're going to make a simple battery using electrochemistry. Now, you're going to need a piece of fruit or a vegetable. It could be a lemon, lime, even a grapefruit. Or you can try a potato or anything else that's wandering around in your fridge. And this is going to be your power source. Now, in addition to these, you're also going to need 2 pieces of metal. Now, these pieces of metal need to be different. One should be copper and one should be zinc. Now, if you don't have just strips of copper and zinc lying around your house, you can also use a penny, preferably minted before 1982. And in place of the zinc plate here, you can use a galvanized nail. Or you can also try a few paper clips, the large paper clips. But the more surface area you have here, the better your battery is going to work. So if you're going to use paper clips, make sure you get a couple of them that are electrically connected together. Okay, in addition to pieces of metal, you're also going to need some wires and a digital multimeter. Now, we're going to measure how many volts your battery gives out, and to do that, the multimeter is actually going to read volts up here. Okay, now how do we build a battery? Well, let me take you through each step. If you're going to use a lemon or a lime, your first step is to actually grab the lemon or lime and squish it in your hands, roll it around and kind of smush it up, but don't squish it so hard that it starts to leak. You want the juice to stay inside. Basically what you're doing is you're breaking up the membranes on the inside of the lime, so the whole thing is one lime instead of having different sections, much in the way you could section an orange. We want that orange to be continuous. You want to break those membranes, and so you're going to have to roll and squish it around a bit for that to happen. Now, if you're using a potato doesn't have any membranes in it, so it's already ready to go. Okay, so your first step is to insert your clips into your piece of fruit or your vegetable. I'm going to go ahead and try a potato. So I have one piece of metal now sticking out of my potato, and I'm going to stick my other piece of metal. You just want to make sure that the 2 pieces of metal don't actually touch inside your fruit or vegetable, your piece of food here. If they do, you're going to create short, and it's not going to produce electricity via chemistry. Okay? You can test how far apart they need to be, or close, or even if that matters at all. So your next step is to connect your digital multimeter to the pieces of metal you have sticking out of your fruit or vegetable. Now, to do that, you can use alligator clip leads. And it looks like this. You want to open up one of your clip leads and simply grab on, just like that. And I can do that one for each side. Alligator clip leads are basically a metal clothespin, and you can easily clip them on. Now the other end goes to your test probes, which are coming off of your digital multimeter. So I have one here, and one here. So I want to form a circuit, which looks like a circle. So if I were to stretch this out, I could follow it with my finger. My red wire connects to my red probe, which connects to here. Inside goes some circuitry. Outside, it comes out of my digital multimeter, and the black wire, which connects back to my potato here. Okay? So you want to set your digital multimeter to read volts. Now on this one, that's going to be 3 clicks over counterclockwise to where it says 20 and then V, DC. And I can read how many volts my potato gives me. And it looks like I have just under 1 volt. Now, what happens if you pick this up and move it over? Does that affect the voltage? What if I put them really close together? Does that affect the voltage? Make sure, again, that they don't touch on the inside. What if I put one on one side and one on the other? It looks like my readings are jumping. If you see a 0.00, that means something's not making good electrical contact. So you might want to check out your connection between the metal tab and your alligator clip, or your alligator clip and your test probe. Wonder what happens if I try it with my lime. Let's give that a try. Now remember, you're going to need to stretch and squish and roll this around in your hands first. Once it feels kind of squishy, go ahead and insert your metal pieces. Now I've got my two metal pieces inserted into my lime. I've made sure they're not touching on the inside of the lime. And my voltage is different than it was on the potato. It's reading a steady 0.865, 0.69. So what's going on here? And does it matter if these are pushed in or pulled out? Does the voltage change? So what's going on? Well, this experiment shows how a battery works using electrochemistry, which is a combination of electricity and chemistry put together. Now, the copper has electrons on it, and those electrons are chemically reacting with the juice inside this lime. Now, the juice inside the lime juice is a pretty weak acid, but when it interacts with that, it forms hydrogen bubbles right around the copper strip inside the lime, and that turns this particular terminal into the positive electrode. Now, the copper ions interact with the zinc over here, and that forms the negative electrode. And we also have zinc ions going on over here. The difference between the two, the difference in potential, the difference in the electric charge on the two plates is what causes the voltage. You can try potatoes, apples, grapefruits, oranges. You can even put these in a glass of water or even salt water. Just make sure they don't touch inside to test to see how much voltage you can get. Voltage is just the difference in charge, the difference in potential. That's all we're looking at here. Now, again, if you don't have these plates, you can substitute a penny and a nail. If you want to try using a light bulb instead of a digital multimeter, well, you're going to have to find a light bulb that actually is an LED, which is a light-emitting diode. You can pick one up from Radio Shack, and you want to make sure that it operates at 1.7 volts or lower. As you can see here, I'm not even getting a full volt on my digital multimeter. So you can either hook several lemons up together to get as much volts as needed to illuminate the LED. Now, just for comparison, if you wanted to light up a flashlight bulb, which, by the way, takes a lot of current to do that, you'd actually need over 500 of these limes all strung up together. An LED uses a lot less current, which is why you can do it with just a couple of these limes. Go ahead and give that a try.